Everyone, so in this discussion we are going to talk about finding the roots of the polynomial of a field. So after the discussion of what is field and how the field structure is and what is a polynomial in field, how to understand what is a polynomial in field. Now, after discussion of the remainder theorem, what is the remainder theorem and its proof, now we are going to work on the example for, that is to find the roots of a polynomial of a field. Here z6 is the field, so f of x is equal to x square plus 3x plus 2 is taken as the polynomial from the field z6. Since it is z6, it has 6 elements from 0 to 5. So the coefficients of the f of x polynomial should lie in the field z6. Okay, so what I do is I take each and every element from the field and I substitute in the function. The answer what I get should be 0 in order to say it is a root of that polynomial. When I substitute 0, I get the answer as 2, that is not equal to 0. Next, I substitute f of 1. When I substitute, I get 6, but 6 is not available in the field, so I subtract from the n value. So n is 7, so mod 6. So if I use mod 6 concept, I get the answer as 0. And the concept of remainder theorem says, and the concept of factor theorem says that if we substitute a value in the function and if the answer is 0, then that value what you substitute in the function is the root. Similarly, when you substitute x equal to 2, you get 12, but 12 is not in the field, so you subtract twice with 6, or you take mod 6, you get the answer as 0. So 2 is also a root of the polynomial. Then you go for 3. So when you substitute 3 in the function in the place of x, you get some answer, that is 20. So 20 is not in the field, so what you do is you use mod 6 concept here. So when you use mod 6 concept, then you get the answer as 2, but 2 is not 0, no? So it cannot be the root. Now you go for f of 4. So when you work for f of 4, same kind, you substitute in the polynomial. You get 30, which is not in the field, so you take mod 6 concept here. So 30 mod 6 idea, so it divides the given term, so you get 0 as the answer. So 4 is a root of the polynomial. Then finally 5. When you substitute 5, you get 42. 42 is not in the field, so you take mod 6 concept here, so you get the answer as 0. So you collect all the values for which the answer is 0. So those values which give the result as 0 are the roots of the polynomial. So hence I come from a set of all elements, that is, here you can see what are all the elements that can be considered as roots are 1, 2, 4, 5. So these are the elements you can consider. They can be easily understood. These are the elements that are having the eligibility to be the roots of the given polynomial. So likewise, you can work on different polynomials of the field. So like this polynomial, you can generate many polynomials where the elements of the given field can be the roots. So we can easily understand, this is the idea, this is the concept by which you can say whichever element forms the root, whichever are not the root of the given field. Okay, the field can have any number of n terms, any kind of n, that is finite elements. So you can choose according to that, you can have according to that. The polynomial can be understood according to the elements in the field. Okay, this is one small example to make you understand how the roots of the polynomial can be found for a field in a very simple manner. Okay, thank you.